All right, hello. We're going to do section 3.3 today, and I will try my best to make it go as fast as possible. But there's a lot of little tidbits here, so feel free to speed up the video if you need to. Anyway, this first thing, it says we're doing Cramer's rule, volume, linear transformations here. So Cramer's rule is another way of that you're going to use to solve equations like ax equals b. I know you have your calculator and everything also, but here is yet another way to do that. So with Cramer's rule, what you're going to do is it involves using the determinant of your coefficient matrix. So this matrix A that they're talking about right here, that would be the matrix made up by the coefficients of the x1 and x2. So 4, 5 down there, and 1 and 2. So I need to know the determinant of that thing. So the determinant of A, and luckily it's just a 2 by 2 here, is 8 minus 5, so 3. Now, this little piece up here, this little part right there, it says determinant of AI of B. And so what that is, when you're trying to make up those matrices, what you do is you replace one of the rows of, or one of the columns of this matrix, if you replace it with the answers. And then you do another matrix and you replace this column with the 6, 7 also. So we're going to make two different matrices. One of them is going to be called A1 of B. The other one's going to be called A2 of B. All right. So in the first one, A1B, we're going to have 6, 7 in the first column. So put 6, 7. And then put the regular 1, 2 back. And then on this next one, A2B, we're going to put the original 4, 5 there. But in the second column, we're going to put the 6, 7. And what we want to do, like it says up here, we want to do the determinant of this. So I'm going to put my lines there, show you I'm doing the determinant. Here I would get 12 minus 7, so 5 up here. Down here I get 28 minus 30, so negative 2. All right. So what you do with those is you take each one and put it over the regular determinant. So if you want x1, you take the answer where you replace the first column with the answer 6, 7, and you take that answer 5 and put it over 3. That is the answer for x1. And for x2, you would do the same thing, but you take negative 2 and put it over 3. So that is the solution to this system of equations right here. Okay. All right, so we're going to do that down below, but we're going to do it for a much larger matrix, and so that makes it a little bit more tedious. So of course with these, you could do, you have matrix A here, it's 2, 1, 1, the coefficients here, negative 1, 0, 2, 3, 1, 3, and go ahead and use your calculator to find the determinant of that. I know the whole point is to not use your calculator, but sometimes we just can't help it. Anyway, or you can do the determinant yourself real quick using one of the things that we've done in the past sections. All right, so let's just pretend we're going to use our calculator to do the determinant of all these things. It really is just the process that you're trying to get down. We know we could do the determinant if we really had to by hand. All right, so I want x1. If I want the answer for x1, I know I'm going to divide something by the 4, like we did up here. All right, so what I'm going to do is make a matrix where the answers 4, 2, negative 2 are in the first column, and then everything else, this column and that column, 1, 0, 1, excuse me, 1, 2, 3 is still there, you would do the determinant of that matrix. So the determinant of that matrix, of that 3 by 3 matrix up there, is negative 16, and the bottom is 4, so I'm getting negative 4 for my first answer. For x2, I would take and replace the second row, or second column, with 4, 2, negative 2, and the rest would stay the same, 2, negative 1, 3, and 1, 2, 3. And then the bottom is still 4. So my x2, that determinant comes out to 52, and then 4 on the bottom, so I get 13. And finally for x3, I bet you can guess, I'm going to replace it in the third column. So this is going to be 2, negative 1, 3, 1, 0, 1, and the last column is going to be 4, 2, negative 2, determinant of that. And so that one comes out to negative 4 over 4, which is 1. So my final solution is negative 4, 13, and 1. That is where those three things meet up. All right, so that's Cramer's rule. You see that here and there, or hear of it sometimes. All right, now, this next thing, this is talking about, there's a formula for finding the inverse. So we've been doing determinants before, but now we're doing the inverse. And so there's going to be a couple little things that you have to think of here. So when somebody is asking for a matrix of cofactors, all right, cofactors, I need you to remember, I forget if we've done it before yet, but when somebody says with cofactors, you're going to need to remember this, the plus minus rule, and then, you know, it could keep going, and then this is minus plus, and so on, and, you know, this is plus minus, and so on. Remember that rule of those spots right there. Now, over here, when somebody does a cofactor, like they go C11, what you're doing is that indicates that you want to do the determinant. You want to do the determinant of the matrix left when the first row and first column are gone. All right, and then we also use the signs to change the signs if we need to. All right, if you were doing C12, that would be the determinant of the matrix when the first row and the second column is gone. So do you see that that's down here and it should be up here? So there's gonna be a little trick to this that you'll see later on, but just so you know what those C's mean. And so this down here, when you use this matrix and put the cofactors in that way and do 1 over the determinant, that little cofactor matrix right there, when you put the cofactors in that order, that's called the adjoint. All right, so if you multiply 1 over the determinant right here by the adjoint, then you get the inverse. All right, so let's see what we're going to do for all this. All right, so first of all, I'm going to always make this little display of my cofactors. So C11, then I would go over here, my cofactor for, this is still the first row, second column, and C13. And then I have the cofactor for the second row, first column, cofactor for second row, second column, cofactor for second row, third column. And then cofactor for third row, first column, third row, second column, third row, third column. And there's going to have answers to these. Now, as we do these, it's going to be easy because I can erase what I'm doing here. But if I'm doing 1, 1, basically the cofactor for that is cross these off and do the determinant of those 4 things left over. So when I cross those off, my determinant comes out to be 0 minus 1, so minus 1. All right. All right, so then next I'm going to go across, and I'm going to cross off and do this spot right here. So cross these 2 off. The determinant of those 4 things left over is 0. All right. And then I'm going to cross off the last one here and here. And then my determinant is 2 minus 0, so 2. So if I do that everywhere, like I keep crossing things off, like I'll do this just this next one, if I cross off here and here. So it gets kind of annoying. But anyway, this would be 0 minus 1. So, oh, I did the wrong thing. Sorry. If I was doing this spot right here, I'd cross this and this off. So those 4 numbers left, I have 0 minus 3, so that would be negative 3. So if I keep doing that, here's all my answers I get: 0, 1, 7, negative 5, and negative 4. All right, so now we have to apply all our sign rules. So remember all these rules that we had up here. All right, so everything that I have to change these things accordingly. So the first spot's going to stay like it is. All right, the second spot's going to get a negative, but that's not going to change it. And the third spot's going to stay like it is. This spot right here is going to change the sign. Then the 0 here, it's not going to matter, but it would be a negative. All right, and then this 1 here, I'm sorry, this would stay positive, and then this 1 here would turn negative. All right, and then down below I'm at a negative, so this would turn negative. This stays like it is, and then this one over here turns opposite, so it'll be a plus. All right, so what I have now is I have -1, 0, 2. Then I have 3, 0, -1. Then I have -7, -5, and 4. Okay, and actually, the -5 I was supposed to switch to a. Oh, I switched up my. Sorry, I messed up. Sorry, you were probably yelling at me. Anyway, plus, minus. This should have stayed. This should have switched, and that should have stayed, right? All right, so that should be a minus. That should be a plus now, and that should be a plus there. All right, so anyway, my answer is going to be that this over here, this 4 is now, it stays negative. The 7 stays positive like it was. Sorry about that. And the 5 in the middle turns to a plus. All right. So now it is still 5. All right. So sorry about that little mess up there. All right. So what we have to do with this, we have to do the transpose of this. So to get the final thing that we're going for right here, I have to take this and transpose it. So my -1, 0, 2. So this is my adjoint. My adjoint is -1, 0, 2 going down the column, then 3, 0, -1, then 7, 5, -4. Okay, so what I have to do is I have to multiply this matrix, the adjoint, by 1 over the determinant of the original matrix. All right, so the original matrix, if you would go and calculate the determinant of that, the determinant of this original matrix is 5. Right, and I did it using this row right here. I crossed this off and that off and multiplied it by 1. So you see I can get 1 minus 6 was -5. And that 1 down there was in a negative spot right here. And so I was able to change that -5 to a +5. That's how I got that. All right, so if I'm doing a -1, I'd multiply 1/5 times this new matrix I have here. All right, so the inverse is -1/5, 3/5, 7/5, 0, 0, 1, and then 2/5, -1/5, and -4/5. And you can check that by typing A in and just hitting the inverse button. So that's kind of annoying. All right, so I'm going to go ahead and do example 6 real quick, but you can go ahead and skip over this if you feel fine with it and you're good with it. But so go ahead and fast forward if you don't want to watch example 6. But it's basically the same as example 5. Okay. All right. So first of all, I need my determinant of this matrix right here. So the determinant of this is matrix A. Matrix A. I'm going to go ahead and use this 3 right here. So I'm going to cross this and cross that. Let's see, plus, minus, plus, minus, plus. So I'm going to keep the 3. When I do my determinant of what's left, I get -3 minus nothing. So I get -3. So my determinant is -9. Okay. All right. So now for my cofactors. So let me get rid of all this stuff that I put on here. So let's see. If I cross off the 1 right here and cross that off and that off, I get -9 minus nothing. So my first spot is -9. Then if I go ahead and move that here and here, I would get 0. And if I move that to the last column, I would get 0. All right. So for the next ones, I'm going to move that to here and here. So my determinant is 6 minus nothing, so 6. So I keep doing that. I get 3, 0, 14, 1, and -3. All right, so now let's change all the signs. The top corner is a plus, so I'm going to keep it -9. The next spot right here is a 0, so it stays a 0. So remember, it went plus, minus, plus, so those stay 0. The next one goes minus, plus, minus, so that would be negative 6, 3, and 0. The next spot goes plus, minus, plus, so that would stay 14, turn to a negative 1, and then stay negative 3. All right, so now for my adjoint. So remember, for my inverse, I'm going to do 1 over my determinant, so negative 9, times my adjoint. So this right here is my adjoint coming. So remember, I take this guy up here and I transpose it. So I have negative 9, 0, 0, negative 6, 3, 0, and 14, negative 1, negative 3. So here is my inverse. 1, 2/3, and negative 14 over 9. And I get 0, negative 1/3, and then 1/9, and then 0, 0, and 1/3. Okay. All right, so the next little bit tells us about excuse me, determinants and what they do to your area or your volume. All right, and so let's just read these couple little rules. If you have a 2 by 2 matrix, the area of a parallelogram is determined by the columns of your matrix. All right, so if what you do, you know, you put in your 2 by 2 matrix, you put your 2 vectors that represent the sides of your parallelogram. You do the determinant, and that's the area of your parallelogram. So let me show you. So we have a parallelogram here. We'll call this A, B, C, and D, I think. So negative 1, 0 is about there. Negative 3, up 3. So negative 1, 0, negative 3, 3. And then 2, 3, so 2, 3, and then 4, 0. All right, so we're going to need to make 2 vectors off the corners of the parallelogram. So we called this, let's see, this is my parallelogram. So it was A, B, C, and D. So to do it, we're going to need like a vector for AB, and we're going to need one for AD. So off the same corner right there. So you got to like line it up correctly. All right, so AB, if you do that vector, you're going to get negative 2, 3. Remember, you do everything in B minus everything in A. And here we're going to do D minus A to get this. We get 5, 0. So what you do with that is you put it in a vector form. I mean, a matrix form. You put negative 2, 3. That's the first vector. The second vector is 5, 0. You do its absolute value, its determinant, and you get 0 minus 15. And so I get negative 15, but remember, this thing says the absolute value of the determinant, so that means that 15 units squared, that is the area of the parallelogram. All right, and a good video to watch too, I put it in the on the Google site, is the video by this chapter 6 video from 3 Blue 1 Brown, and it explains all these things and like gives you nice pictures and everything like that. All right, so the second rule on that last page was talking about volumes. So a parallelepiped, remember, is that like kind of like a squished prism in a way, like squished over to the side like a diagonal looking prism. All right, what that's going to do is if you do the absolute value of the determinant, where the columns are the 3 vectors coming off the corner, then what that does, it gives you the volume. So we're going to do that here. So, this picture is not for these points right here, but basically these points, your origin, it says that the volume of a parallelepiped with one vertex at the origin. So yeah, this is at the origin, and then these points right here are like your points here, here, and here. So you have those vectors going off from that point right there. So what you do is you take your 3 vectors and put it in a matrix. So you do 1, 4, 0, and negative 2, negative 5, 2, and then negative 1, 2, negative 1. And you do the determinant of that. And so you have all your ways. You have the determinant, you can do the determinant, or you can put in your calculator, nobody's going to know. Anyway, you get negative 15. So that tells me that I do the absolute value. So 15 units cubed is the volume of the parallelepiped. Right, and it just so happens that the last answer came to 15, and so did this one. Okay, now, what's also important to notice is that if a matrix is doing a transformation on a shape, and how that affects that matrix affects the area or the volume of that shape. And so it tells you right here, so you can come back and read it after I show you this example. But basically, if you do a transformation on something, the determinant of your transformation is the factor by which it affects the area of the original item. Okay, so let's look at this one last example right here. All right, so it's also talking about it up here too. So we have a parallelogram with these two vectors. All right, so it's kind of like the first example we did in this little part, and we have this transformation right there. All right, so let's do what we know before. If you had 4, -7, and 0, 1, you had that parallelogram. If you did the determinant of this matrix, you would get 4 minus nothing, you get 4. So that would be the area of the original parallelogram, so units squared. If I was looking at this transformation matrix, if I do the determinant of that, determinant of A, I would get 7 minus 2, so that'd be 5. Okay, so it turns out that if you apply this, this transformation to this parallelogram, then it's going to affect the area of that parallelogram by a multiple of 5. So the new area of the whole thing after you do the transformation is going to be 20. So watch and see. So you want to apply A to this parallelogram. So we're going to take 7, 2, and 1, 1. We're going to apply it, and to apply a transformation, you multiply 4, -7, 0, 1. So you multiply that 2 by 2 times another 2 by 2, and you get 14 and 2, -3 and 1. And guess what? That new shape right there, you do your crisscross, your determinant is 14 minus -6, which is 20. And you can see that, 4 times 5 equals 20. And it kind of proves what we were saying. All right, so I think in this homework right here, 5, 11, 21, 23, and 27, I think I probably maybe cut 1 or 2 off, maybe just 1 off of your green sheet. I think that's what I'll do from now on, is like kind of tell you at the end here, like if I want to cut off any problems to make it a little bit shorter. But that is it. I'll talk to you next time.